Let me just record the, share the screen. Okay, last time we finished with P of A, B, C. Actually, A intersection B into the C is equal to P of A, P of B given A, and into P of C given A and given B. Okay, this is the last theorem that we did. Remember? Okay.
Yeah.
Now we are going to deal with Bayes theorem. Very interesting theorem. It's very helpful theorem. Okay, very helpful theorem. Before I start, what the formal thing is, look at this place. Okay, example 8.31. There are two bags. Bag 1 contains 3 red balls and 4 blue balls. Bag 2 contains 5 red balls and 6 blue balls. One ball is drawn at random from one of the bags and it is found to be red. Find the probability that it was drawn from the second bag. Okay. Now, this is a different type of problem that you have never encountered before. All right. In your 10th and 9th standard, only one bag will be there or one urn will be there, and you'll put your hand inside that and you'll calculate the probability of the among the balls inside a single bag. Okay. Now, you have two different types of things. Here, there is a chance of the probability of taking from bag 1 and the probability of choosing bag 2. These are two different probabilities. Okay. The probability of choosing bag 1 and the probability of choosing bag 2. Let us keep it as E1 and then E2 probability. P of E1 and P of E2. Now, choosing one red ball. Okay. That is another kind of probability. That is another event. Okay. Do you understand?
Yeah.
Choosing bag 1 or choosing bag 2, that is one event. Choosing a red ball from some bag, okay, that is another event. So there are two types of events here, two series of events. Okay. Now come back to Bayes theorem here, you will understand this very much. If E1, E2, E3 to the up to E1, En are a set of n mutually exclusive and collectively exhaustive events. Okay. Now, for example, there are only two bags, so it is collectively exhausting. Either you can take from bag 1 or you can take from bag 2. Okay. So it is collectively exhaustive events. Then if you take from bag 1, then you are not taking from bag 2 automatically. If you take from bag 2, you are not taking from bag 1 automatically. So they are mutually exclusive events also. So this is a perfect example. Like that, E1, E2, E3 up to En are mutually exclusive events. Here we have only E1 and E2. There are only two mutually exclusive events. You could have had 5 bags, 6 bags, 7 bags, and put balls inside all of that. Then it will come on to E of N. You understand?
Yeah.
So E1, E2, up to En are N mutually exclusive and collectively exhaustive events. And P of E of 1 not equal to 0. That means you cannot choose bag 1, impossible event. It should not be, nothing should be an impossible event. Okay. So you must be able to put your hand inside bag 1. You must be able to put your hand inside bag 2, inside bag N. Okay. So that is then, if that is case, then for any arbitrary event A which is associated with sample space, U is equal to, very small, it is written, U is equal to universal I equal to 1 to N, E of I. Okay. So this sample space is nothing but, okay, it's associated with E of 1, E of 2, E of 3 up to E of N. That's what it means. This means nothing else. Okay. All the events are put inside a sample space. Now, what you want to do, you don't bother about this thing. S equal to U, I equal to 1 to N, E of I. Don't bother about it. What it means is some other event, taking a red ball. Okay, that is some other arbitrary event. Okay, it has got nothing to choose between choosing the first bag or second bag or third bag or nth bag. Okay, that is a different class of events. Another arbitrary event, choosing a red ball, is a different event. Okay, but this event is associated with the events E1 to En. Okay, because it is from one of these bags that the red ball is chosen. Okay. Such that P of A greater than 0. That means that also should be a possible event.
Uncle, what's arbitrary event?
Impossible event. Yeah.
What is arbitrary event?
Arbitrary event means some event, no connection to bags. See, inside the bags, you can have katrika inside each bag. Instead of that, you are having balls inside each bag. Okay, so there is no connection between choosing which bag, one bag, bag 2, bag 3, bag 4, and no connection between choosing a red ball or a green ball. Okay, Arbitrarily you put balls inside that way.
Or randomly அந்த மாதிரியா?
Without any necessary connection. Okay, சும்மா வந்துருச்சு ஒரு தற்செயலான்னு சொல்லுவாங்கல்ல தமிழ்ல. தற்செயலா அது வந்துருச்சு, incidentally or accidentally, like that is arbitrary.
Okay.
Then what is a formula? What happens now? P of I given A, P of E given A, the probability of choosing bag 2, okay, for example, the probability of choosing bag 2, given that you have already chosen a red ball, you should read like that. You understand what this P of E of A? P of E by A, P of E of I by A means the probability of choosing bag 1 given that you have chosen a red ball. Okay, which event has happened? Event A has happened. You have chosen a red ball, and so the probability that you have chosen it from E1, bag 1. Okay, like that you should read. So probability of E of I bar A is equal to P of E of I into P of A by E of I. Okay, the ulta. See, remember how the formula comes. Idunode ulta adu.
Okay.
One minute. The probability of choosing from bag I, some bag, given that you have already chosen a red ball, okay, is equal to the probability of choosing the bag into the probability of choosing a red ball, okay, provided it is from the first bag. Okay, so here the probability of choosing a bag provided you have already chosen a red ball. Okay, here this is the probability of choosing bag 1. Okay, there the probability of choosing a red ball given you have already chosen the bag 1. Okay, the ulta. Okay, that is divided by sigma of the same. Everything becomes P of E of I into P of A divided by E of I, given E of I, and it's not divided by bar E of I. See, what is here, it will come here. What is here, it will come here. What is the only difference? Sigma. Here it is E of particular number. Okay, here it is sigma I equal to 1 to n. Okay, that means this will come many times. Denominator will come many times. All right, denominator will come first time. It will come P of 1, P of E of 1 into P of A given E of 1. Then second time it will come, you have to add it with P of E of 2 given P of A, sorry, P of A given P of 2, E of 2. Then third time it will come plus E of 3, okay, into P of A given that E of 3 has happened. Like that it will go on. So that's sigma. Okay, now you understood the formula and now you understood the event. Now, unless we do worked out as a problem, you will not understand the whole thing clearly. Okay. Let E1 be the event of choosing the first bag. Okay. Let E2 be the event of choosing the second bag. And A be the arbitrary event of drawing a red ball. Okay, A is the arbitrary event. It is not connected with the choosing the bags. Okay, E1 and E2 are similar events. They are all about choosing from which bag. A is another event. It is unconnected to this. Okay, but associated with this, which is choosing a red ball. Then now you see P of E of I. There are only 2 bags. Let us say this is bag 1. This is bag 2. Okay, between these 2 bags, okay, this is only the sample set. Bag 1 and bag 2. CS is equal to bag 1. So, what is the probability of choosing bag 1? Half. What is the probability of choosing bag 2? Again half. Okay, so that is why he has given. Either you can choose. So, how you get n of choosing a bag 1 by n of s. That is equal to 1 by 2. Like that. N of choosing bag 2 by n of s. Again 1 by 2. Okay, this is how you have to understand that. Very easy. This is all 9th standard mathematics. 9th standard probability. Okay, now P of A, P of choosing a red ball, given that bag 1 has been chosen. How should you read this? How should you understand this? P of choosing a red ball, given that bag 1 has chosen.
Okay.
Bag 1 is already chosen. So this fellow has put his hand inside bag 1 already. Then what is the probability that he pull out a red ball? That means how many red balls are there inside bag 1?
3.
Only 3 red balls are there. Blue balls are there. Okay. Yeah. So that probability is 3 by 7. Why? Because 3 by 3 plus 4.
3 plus
4 Total sample space is 3 plus 4.
That's 7. Yeah.
Number of favorable events is
3.
For red ball is 3. So 3 by 7. Okay. So that is how you got 3 by 7. You understood this. Same way, probability of choosing a red ball, given you have put your hand inside the bag 2 already. You put your hand inside bag 2 already. What is the probability of pulling out a red ball from bag 2 now? So bag 2 contains 5 red and 6 blue. Okay. So 5 divided by 5 plus 6. Okay. It's 5 by 11. Okay. This is how you got this. You understood how you got this?
Yeah.
Okay. You understand all of that, then it is only a matter of applying the formula now.
Okay.
Okay. So what have you got? Now you got P of E of I, E of 1. You know P of E of 2. You know P of A given E of 1. You know P of A given E of 2. All 4 is known now. Okay. Now what you need to know? You know to know P of E of 1. Because what? Event of choosing the first bag. Okay. Is telling find the probability that drawn from the second bag. Okay. So what you have to find out is P of E of 2 given A. That only you have to find out. What is his meaning? His meaning is he's pulled out a red ball. What is the probability that the red ball is taken out from bag 2? Okay? You understand what this means?
Yeah.
Find the probability that was drawn from second bag means find P of E of 2 given it was a red ball that was pulled out. So find the probability that given that the red ball was pulled out, what is the probability it was taken from the second bag? Okay. Always the event is under the bar is done first.
Okay.
It's already happened. The event above the bar is conditional on that event already having happened. Okay. So that is why this is going to happen. This is going to happen. So it's going to be from the second bag. Okay. It's going to be from the second bag. Okay. It is already pulled a red ball. What is it? It is going to be, if it is going to be from the second bag. What is the probability? That's what you have to find. So you have to find P of E2 given A bar. Now, the probability of drawing a ball from bag to being given that it is red is P of E2 bar A. That's what he is telling that. Okay. Now, let us apply the formula of Bayes theorem. Now, you have to apply Bayes theorem. Okay. P of E2 given A. That's what you have to apply. Okay. Is equal to, now you already know the formula. Okay. What is the formula? P of E of I given A is equal to P of E1 EI into P of A by EI divided by sigma of P of E of I divided by sigma A by E of I sigma. Okay, sigma means adding everything. Okay. Now P of E of 2 is what? Half. Probability of choosing bag 2 was half. So this is half. P of A given E of 2, we already saw.
Okay.
P of A given E of 2, how much? P of A given E of 2 is equal to 5 by 11. Okay? 5 by 11. So this one is this is half, this is 5 by 11. Okay. So that is why he's put half here, he's put 5 by 11 here. Okay. Half into 5 by 11 divided by sigma. Sigma means you have to add up everything. First one is P of E of 1 into P of A given E of 1. P of E of 1 also half. P of choosing bag 1. P of A given E of I is 3 by 7. We did that. Probability of choosing the red ball given that it is from bag 1. Okay. Probability of choosing a red ball from bag 1. That is okay. So you get half into 3 by 7. Second round is P of E of 2 into P of A by E2. second round. Okay, into. Now P of E of 2 again half. Okay, this is half into 3 by 7. You got half into 3 by 7. This is again half into P of A given E by 2. This time it is 5 by 11. Okay, that is probability of drawing a red ball given that you are doing it from back to from back to pulling a red ball was 5 by 11. Okay, now you multiply all of this. 1 by 2 into 5 by 11 will be 5 divided by 22. Okay, top this part, 5 divided by 22. Okay, 3 by 14 plus 5 by 22. Okay, 3 by 14 plus 5 by 22. Now 22 into 7 will give you 14, 154. Okay, take LCM 154. Multiply by 7, multiply by 7. This is equal to 35 by 154. Here also multiply by 7, multiply by 7. Plus 35. Here you multiply by 14 into 11. 3 into 11. 33 by 154. Okay, 14 into 11, 154. 35 plus 33, how much? 868. Okay, so this will become 35 by 154 divided by 68 by 154. Cancel both. So you get 35 by 68. So that is the answer. Okay. So this is a very interesting type of sum. Once you understand it, we will do 2 more examples. You will definitely understand it. Then we'll let me go and try the exercises. Example 8.32. Let us now do. Very interesting example. X speaks the truth 4 out of 5 times. Okay, X speaks the truth 4 out of 5 times. Okay, that means let us have one event E1 speaks the truth. Okay, 4 out of 5 times. P of E of 1 is equal to 4/5. Then let us have another event which is mutually exclusive. Yes, P of E2. Yes, X does not speak the truth. Okay, that is equal to 1 minus P of E. That is equal to 1 minus 4/5. That is equal to 1/5. Okay, so E1 and E2. He speaks the truth. He does not speak the truth. One class of events. Okay. Now another arbitrary event is happening. He is reporting there is a 6. Okay, reporting there is a 6. What is the chance that actually there was a 6? So we are going to find out P of okay, E1 speaks the truth. Okay, E1, E2. Okay. That there was a 6. How you require? So he spoke the truth, and instead of E, let us take this as A. Okay, P of E1 given A. A is he actually reports as 6. Okay, that's an arbitrary event. So we have to find out there was a 6. That is equal to what is this? You have to find out. How this means that given that, okay, given that he said that there was a 6. What is the probability that okay it was he actually spoke the truth? Okay, given that he reports as 6. What is the probability that he spoke the truth? Okay, you understand what this means? P of E of I by A means, given that this fellow reported a 6, that is, he gave an arbitrary event. There is a 6 that has fallen. Okay. Now, what is the probability that he spoke the truth? He spoke the truth, P of E of I, 4 by 5. He did not speak the truth, 1 by 5. Okay, E and E1. Now, A is, now he actually reports a 6. He actually says 6 fell. That is a arbitrary event. Okay. Now, from the data given, P of E of 1 is 4 by 5, P of E of 2 is 1 by 5. We saw how. Okay, he reports 4 out of 5 times, he speaks the truth. So that is 4 by 5. Okay, 1 minus 4 by 5, you will get E of 2. So these are exhaustive events. No other possibility. Either he's speaking the truth or he doesn't speak the truth. So Bayes theorem is satisfied. Okay, mutually exclusive and exhaustive events. So therefore you can now use the formula. Okay, before that we have to write, now you write P of A given EY. Okay, don't put E, put A. P of A given E of I. Okay, this is given that he speaks the truth. What is the probability that there is a A? Okay, so he has spoken the truth. The sample space is going to be like this. Okay, how many sixes are there in the sample space? There is only one six. Okay, so n of A is equal to 1. N of S is equal to 6. 1 by 6. So this is 1 by 6. The probability that he is speaking the truth. When he speaks the truth, the probability that there is a 1 by 6. There is a 6. Okay, the probability that there is a 6 when he speaks the truth. Okay, that is 1 by 6. So he is given that as 1 by 6. You understand this thing?
Yeah.
Okay. Providing he has E1, he has spoken, when he has spoken the truth, what is the probability that there will be a 6? Okay, அவன் உண்மையை பேசிட்டான். அப்போ அந்த டைல வந்து 6 வந்து உழறதுக்கு என்ன சான்ஸ் இருக்கு? அவ்வளவுதான். The chance is 1 by 6. Okay. Now, this fellow is now spoken a lie. He's spoken a lie. What is the probability of getting a 6? Okay, that means he has said that there is a 6, but actually there is not a 6 because he has told a lie. So what all has come? 1, 2, 3, 4 or 5 has fallen. Understand? Sample space is 1, 2, 3. I mean, A, event A is now 1, 2, 3, 4, 5. Except 6, all other numbers can come. Okay, so now n of A is 5. N of S is 6. So that probability is 5 by 6. Okay, that is why he is given here 5 by 6. Probability that, A occurs given that he has spoken a lie. All right? Yeah. So he is told there is a 6. Probability that there is not a 6. Okay, that is 5 by 6. You understood this thing? Very important. Very important. Now the required probability that actually there was a 6, you can calculate. What I said you must calculate. P of E of 1 given A. Given that there was a 6, given that there was, he reported a 6, what is the probability that there was actually he was speaking the truth? Okay. So P of E of 1 by E of by E. P of E of 1 by A. This is A. Okay. Wherever E comes, you put A. Otherwise, you won't understand. Okay. P of E of 5 given A. Given that he has reported as 6, what is the probability that it is actually a 6? He's spoken the truth. Okay. The probability that he's spoken the truth. So you apply the formula now. P of E of 1 into P of A given E of 1. Okay. P of E of 1 is 4 by 5. This place. P of E of 1. Okay. 4 by 5 into P of E of 1 into P of A given E of 1. P of A given E of 1 is 1/6. Okay, this one 1/6. Now divided by, you have to do sigma. Sigma is same thing, no? For first one, P of E of I into P of A given E of 1 plus P of the other one, E of 2. E of 2 is 1/5. Given that, and P of A given E of 2. P of A given E of 2 is 5 by 6 into 5 by 6. That is what he's doing. Okay. 4 by 6, 4 by 5 into 1 by 6 is equal to, this will be 4 by 5 into 6 is 30. Divided by 5 into 6, 5 into 6, both 5 into 6, 5 into 6. 4 plus 5. Okay. That is equal to 4 by 30 divided by 9 by 30. Okay. 4 by 30 into 30 by 9. You cancel 30, 30, you will get 4 by 9. That is the answer, 4 by 9. You got it. Now let me post this in your WhatsApp. Now let us go for a slightly different kind of example. This will be asked in your exam. After this, we go for exercise 8.2. A factory has 3 machines, A1, A2, and A3, and producing 1,000, 2,000, 3,000 screws per day respectively. Okay, so that means first thing is probability of A1. The screw is manufactured by the first machine is 1,000 by 1,000 plus 2,000, 3,000 plus 6,000. 1 by 6. Okay. Probability that screw is manufactured by A1. Then probability screw is manufactured by A2 is 2,000 by 6,000. That is 2 by 6, 1/3. Then probability that screw is manufactured by A3 is equal to 3,000 by 6,000. That is 3 by 6 equal to half. Okay. 1/6, 1/3 and half. Okay, that you are. This is the first level. These 3 events are, okay, they are 3 different, let us say this is E1, not E1, E2, E3. So E1, E2, E3. 1/6, 1/3, half. Okay. So which machine the bolt is manufactured from? The screw is manufactured from. Okay. E1, E2, E3. Let us do it in the let's do it in the whiteboard. Okay. Here E1 is 1/6, E2 is 1/3, E3 is half. It is half. This is very important sum. If you get it clearly, then you are getting everything clearly. You can answer exercise 8.2 clearly. Now A1 produces, now let us take it as E1. E1 produces 1% defective. Probability of defects are, okay. Now probability that it is a defective event is equal to A. Event of probability that it is a defective is equal to A. Okay. So now probability that it is defective, but it is produced by machine, first machine, okay, is equal to 1 by 100. Because what? 1% defective. Then probability that it is defective, given it is produced by machine A2, is 2%. Then probability that it is defective, given that it is produced by machine E3. You understand?
Yeah.
First. So already E1 machine has produced, then you find out if it is defective. Already A2 machine has produced, you find out if it is defective. Already E3 machine has produced, find out if it is defective. Okay. So this is 2%. So this is 2 by 100. This is, sorry, 1.5 by 100. 1.5 by 100. This is 2 by 100. Now what we have to find out is saying, what is the probability Okay, a screw is chosen at random at the end of the day and found defective. What is the probability that it comes from machine A, machine A1? Okay. Now, defective screw is chosen. Okay. Defective screw is chosen. This is coming first. What is the probability that is coming from machine A1? Okay. This is coming second. This only you have to find out. Okay. Now, very simple. You have to just apply the formula. You know all of this. Okay. You know P of I is equal to P of I is equal to 1/6. P of 2 is equal to 1/3. P of P of 3 is equal to half. Okay, now you know all of this. Then you know P of A given E of 1 is 1/100. P of all. Now what you have to do? P of E of 1 given A you have to find out. That is equal to P of E of 1 into P of A given E of 1 divided by sigma of P of E of I into P of A given E of I. So we have E of 1, E of 2, that is equal to P of E of 1 is how much? 1/6. All right, this one. P of E of I, 1. Okay, into P of A given E of I, that is equal to 1/100. Okay, you understood? Where it is? This one. P of A given E of I, 100. Into sigma means first one is P of E of 1 into P of A given E of 1 plus P of E of 2 into P of A given E of 2 plus P of E of 3 into P of A given E by 3. This is the whole formula. What? Okay, what to do? Okay, then no problem. Okay. Now 1/6 into 1/100 divided by P of E of 1 is 1/6 into 1/100 plus P of E of 2 is 1/3. This one, no? P of E of 2, 1/3. Okay, into P of A by E2. P of A by E2 is 1.5/100. So let us put 0.015. Okay, we'll put 1.5/100. 1.5/100 into P of A by E3. P of E3. P of E3 is half. P of E3 is half. Half into P of A by E3. P of A by E3 is 2/100. Okay, 2 and 2 will go, you'll get 1/100. Okay, now this will be equal to will be equal to 1/6 into 1/100 is equal to 1/6000 divided by 1/6 into 1/100 plus 1/3 into 1.5/100 plus plus half into 2 by 100 is equal to 1 by 6,000 divided by 1 by 6,000 plus 1.5 by 3,000. 1.5 by 3,000 plus 1 by 100. You put 10 by 1,000. Okay. You take LCM for all this 6,000, 3,000. Divide again by 6,000 into 6 into 6, 60 into 2 into 2, 3. This is 1. Okay. So that is equal to 1 by 6,000 divided by 60 plus 3 plus 1, 64. 64 by 6,000. Cancel both, you get 1 by 64. Okay. That is the P of E. Defective bolt is chosen. Defective bolt is chosen, but it is chosen from machine 1, machine A. All right. We can do 1 by 64. It's coming, different answers coming. Not went wrong. 1/3 into 1/3. Sorry, this whole thing is wrong. Whole thing calculation is wrong. Okay. 1/6 into 1 by 100 equal to 1 by 600 divided by 1 by 600 plus 1/3 into 1.5 by 100. Okay. Plus half into 2 by 100. So that is equal to 1 by 600 divided by 1 by 600 plus 1.5 by 300 plus 1 by 100 into 1 by 600 divided by 1 by 600 plus make it 600 everywhere into 2 plus 3 into 6 plus 6. Okay, that is equal to 1 by 600 divided by 3. 6 plus 3 9, 9 plus 1 10. 10 by 600. Cancel 600, 600. Answer is 1 by 10. Okay. Yeah, that is the correct answer. Some calculation mistake. I did 6,000. So this also I will based on your screen. Let me put it on WhatsApp. The other one disappeared.
Uncle, why did you take 1 by 6 into 1 by 100? Uncle?
The other thing is disappeared. I should have pasted that before taking this. Okay.
Yeah,
what
Uncle,
is what is the answer?
Why did we take 1 by 6 into 1 by 100?
1 by 6. P of machine 1. P of machine 1.
That's 1 by 6.
1 by
okay,
6. And
but why into 100?
P of getting a defective one. 1%, no. So 1% means 1 by 100.
Okay.
So 1.5% means 1.5 by 100. P of A given machine
Okay.
2.
Okay.
P of A given machine 3 is equal
Okay.
to 2 by 100.
Right, understood.
Yeah,
Yeah.
percentage. This is 1% error, 1.5% error, 2% error. That is what you are substituting here.
Okay.
P of A given E3, V2, P of A given E3, P of A given E2. This is 1/6 into 1 by 100, 1 by 600. This is P of A given E1. Okay, this is P of E1. This is P of E2. This is P of E3. Same way, upper one also 1/6 by 1 by 100. This is P of E1. This is P of A given P of A given E2, E1. Okay. See, the calculation is not a big problem. What you have to find out is how do you interpret the problem? Okay, you have to interpret it. So the important step is, first thing is P of E1, machine E1. The probability that you will get the bolt from, what is the event? Event E1 is probability that A, machine A manufactures, that is equal to 1000 by total number of screws. That is 1/6. That is the important one. This one is important. Then probability of E of 2, like same way, 2000 by 6000. That is equal to 1/3. And probability that it is from machine 3. The bolt is manufactured by machine 3 is 3000 by 6000 is half. Okay. This is the main important step. The events. These events are mutually exclusive. Why? Why they are exhaustive and why they are mutually exclusive? Because if the bolt is manufactured from E1, then automatically it is not coming from E2 and E3. Same way, they are exhaustive events. Why they are exhaustive events? Because there are no other machines. Only you can manufacture from A1, A2 or A3 machines. Okay. Only you can manufacture from A1, A2 or A3 machines. So they are mutually exhaustive. Okay, they are exhaustive events also. Therefore, Bayes theorem applies. Bayes theorem applies. So you got three events E1, E2, E3, which are bolt is manufactured by a machine. That is event series. The other arbitrary event is one of the bolt is a defective bolt. That is arbitrary event. This event A is that the bolt is defective. Okay, this is not connected. Manufacturing is one thing and defect is another event. But the two are associated. How they are associated only Bayes theorem is saying. So P of E1 given A, you are asked to find out. What is the, how you know that you are asked to find out P of E1 given A? Because they are saying what is the probability that comes from machine A? A bolt is manufactured defectively. What is the probability that it comes from machine A? Okay, already it is manufactured defectively. So A is at the bottom. What has already happened, what is first coming is at the bottom. Okay, which machine it is coming from is at the top. So that is machine A is at the top. If you had asked instead of machine A, what is the probability it comes from machine A? You should be finding out P of E2 by A. All right. Suppose he is asked what is the probability that the defective bolt comes from machine 3? You should find P of E3 by A. Then what will change? Nothing. Very simple. P of E3 into P of A given E3 divided by P of E1 into P of A given E1 plus P of E2 given P of A given by E2 plus same thing P of E3 into P of A given E3. That's all. Only thing is the numerator will change. You understand? Only the numerator part will change. If he's saying you find out the bolt, defective bolt is from machine 3, on the top you have to put P of E3 by P of E3 into P of A by E3. Okay. Numerator will change. Denominator will always remain sigma P of E of I into P of A by E of I. Denominator will always remain the same. You have to calculate for all the three, or you have to calculate for all the two. If they give 5 machines, you have to calculate for all the 5 machines. P of E of I and P of A by E of I, you have to calculate. You understand?
Hmm.
I think fortunately for you, they ask either 2 or 3 only. Bayes theorem. 3 events or 2 events maximum, even E2 or even E2, E3. So very simple problems you can have. Okay, let me post this also. Okay. Now let us go to the exercises. Okay. A family has 2 children. What is the probability that let us do these problems now. We'll take up some homeworks here. A family has 2 children. What is the probability both the children are girls, given that at least one of them is a girl? Okay, sample space for 2 children. Either it is a girl, first one is girl, second one is girl. First one is girl, second one is boy. First one is boy, second one is girl. Or first one is also boy, second one also boy. Okay, this is the sample space. Now, what they are given, at least one of them is a girl is already given. That means this you cannot include. Both of them are boys, you cannot include. So the sample space is now actually either both of them are girls or at least one of them is a girl. Okay, so there are sample size is equal to n of s equal to 3. Now, what is the probability that both the children are girls, given that at least one of them is a girl? Okay, both the children are girls. What is n of both the children are girls? Is equal to 1. Okay, what is the probability that no? What is the total sample space? Total sample space equal to 3. Okay, so n of this is equal to p of gg, or you can name it as p of g. Both are girls. Okay, both are girls is 1/3. Very simple sum. Okay, where you have to be careful, given that at least one of that is a girl. Okay, that means only you can take these 3. You cannot have both are boys. Okay, so your sample space reduces here. So sample space correct. Okay, correct sample space. You understand? After that, this is a simple sum. This is from your 9th standard. This is not really your 11th standard thing. Okay. So exercise 8.21. Let me post it in your WhatsApp. You understood that, huh? Venki? Hello?
Yeah, uncle.
You're there.
Yeah.
Because I don't know if you have gone out or something. Here there is power failure.
Oh,
so
okay.
that's why I'm thankfully my thing is on a inverter. My Wi-Fi is on an inverter. Okay.
Okay.
Now I think you are finding something confusing there. What you are finding confusing, you tell me. I think you are finding why I eliminated B1 into B2. B1, B2 because the problem is telling, given that at least one of them is a girl. So they are already telling out of the 2 children, one of them at least is one is girl. At least one is girl. So in B1, B2, both are boys. At least one is girl condition is not coming. So you have to remove that. So the actual sample set is now reduced to only 3. Sample size is 3. N of S is 3. For first child is girl child, second child also girl child. First child is girl child, second child boy child. That is also a possibility. First child is boy child, second child is girl child. That's also a possibility. Both the children are boys, not a possibility because at least one is a girl. So that becomes your sample space. Out of the sample space, they now are asking, what is the probability that both the children are girls? Okay, this is not Bayes theorem or any theorem. This is common sense probability or elementary probability. N of S by N of A by N of S. Okay, let us say the event that probability both the children are girls. What is the probability? Both the children are girls. That is only your finding. Instead of N of A, I said both the children are girls. And the gene vechikalam. N this stands for both are girls. What is that probability? Or gene vechikalam. Okay. You keep it as D. Don't put GG. So probability of G is out in the sample set. How many are both girls? This is girl. This is also girl. Is this girl? This is also girl. No.
No.
This girl, this is also girl. No. So
No.
this is not there. This is not there. Only
Okay.
this outcome is our favorable outcome. Okay. So what is the probability of A? Number of favorable outcomes by total number of outcomes. Remember, this is 9th standard mathematics.
Yeah.
So he is given this sum just to confuse you. Okay. So I finished that sum because it will confuse you. I finished that. Okay, we already posted this. Let me post it again. Okay, now let us do second sum. Exercise 8.2, second sum. A die is thrown twice and the sum of the number appearing is observed to be 6. What is the conditional probability that number 4 has appeared at least once? Okay. This is also a slightly confusing problem. Okay. A die is thrown twice and the sum of the number appearing is observed to be 6. Okay. Now you throw it first time and sample space is equal to 1, 2, 3, 4, 5, 6. Enough sample space equal to 6. Okay. First time. Or we will take the other example. 2 times. Let's not take it like this. 2 times it's occurring. Two times it's occurring. Total sample space equal to 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6 like that. 2, 1, 2, 2. You know this, you have done this already.
Yeah.
You have to write. It's a very long sum. Whenever dice comes. Okay, this is the sample space. The sum of the number appearing is observed to be 6. Where all is 6? This one is 6. This one is 6. This is
3
6.
plus 3.
This is 6. This is 6. That's all. 1, 2, 3, 4, 5 events. 5 events are 6. This is n of sample space is 36. Okay. Right. Now he's asking, what is the conditional probability the number 4 has appeared at least once?
2, 2,
The number 4 has appeared at least once.
2,
Here and here.
Okay.
Okay. It is only here and here. Okay. Now, what we have to do? The first time the sample space, how to say that I'm trying to wonder now. Okay. Now all the numbers where you can have 4. I mean, you can have 6s, 1, 5. Okay, 2, 4. Then 3, 3. 4, 3, 1. Okay. Event 6 occurs. This is the event. Okay. Now, event B is 4 occurs. 4 is the sum. 4 is the sum. Sum is 6, 4 has appeared. Okay. This is event A. So that is n of event A is 5. Okay. 1, 2, 3, 4, 5. So n of event A is equal to 5. So probability that it is a 6. Probability that it is a 6 is equal to 5 divided by 36. Because n of A divided by n of a sample space, 5 by 36. So 6 occurs is 5 by 36. Okay. Now probability that it is this is event B. 4 is a number inside that. 4 is a number inside that is event B. Okay. Now we are going to apply the conditional probability. Given that event A has happened, what is the probability that event B will occur? Given that sum is 6. Given that sum is 6, what is the probability that 4 appears? You understand? What are we finding? Probability that 4 appears, given that 6 has already appeared. You remember the formula P of A intersection B?
Yeah, I remember. A little bit.
So P of A intersection B. What is the intersection between these two? Event B is 4 is a number. So B is equal to 4 is occurring here. So 2, 4.
And
then
4,
4 is occurring here also. 4, 2. So n of B is equal to 2. Okay. So this is A intersection B. So N of A intersection B is equal to 2. So P of A intersection B 2 by 36. P of A intersection B by P of A will be 2 by 36 divided by 5 by 36. Cancel 36, you will get 2 by 5. Okay, this is the way to do it. So slightly tricky sum, very vague sum. If it comes in your exam, don't do this sum. Just skip it. Don't answer this sum. I don't like this sum. Mentally itself, you can calculate. Okay, mentally you can calculate. You know that this is one is coming, this is one is coming, but that is not out of the total size of 36. Okay, so that is 2 by 36 is A intersection B. Of A intersection B. So the formula P of B given A is P of A intersection B by P of A. Yeah. So P of A intersection B is 2 by 36. P of A you already find out is 5 by 36. P of A is 5 by 36. Okay, and P of A intersection B 2 by 36. 2 by 36 because only these two events are picked out of the main events. Only 2 by 4 and 4 by 2 are picked out of main events. Why is it called A intersection B? Because out of them, sum is 6. Okay, where both sum is both 6 and both sum is 6 and 4 appears. Both sum is 6 and 4 appears. So when both and comes, it is intersection. So both sum is 6 is A and 4 appears is A. So B. So P of A intersection. Understood that?
Yeah.
Either it is 6 or 4 appears. Either R means union. Either A occurs or B occurs means A union B. Both A and B occur is meaning A intersection B. Okay, you remember this. This is from 10th standard, 9th standard on all that. Okay, both A and B means A intersection B. So here only you are writing A intersection B. So it is both 6, sum is 6 and 4 is appearing. So that probability is 2 by 36. Then you take the conditional probability formula and P of B given A. Probability that 4 appears given that 6 is already a sum. Okay, is P of A intersection B by P of. That is all. I'm going to post this also. These two are from previous era. This one is from the current one. Let us take the third problem now. An unbiased die is thrown. You're running out of time, huh?
Yeah. Time is over.
Okay, what to do? Can you do 3 for homework?
Yeah, sure.
Do 3 for homework and come. It is very similar.
Okay.
Check whether A and B are independent events. How you will find out? Okay, you have to find out P of A into P of B is equal to P of A intersection
B. Yeah.
If you understand, then A and B are independent. Okay. So that means you have to find P of A first step, P of B second step, P
and
of
then
B
intersection.
third step, and then see if multiply these two and see if it is equal to the second one. LHS equal to RHS.
RHS. Okay.
LHS equal to RHS, then you have proved that they are independent events. Okay. Do third sum. It's getting very late.
Yeah.
Just do. Okay.
Uncle, can we have the Saturday class on the evening?
Can you have what?
Saturday class on the evening.
Can you have what?
Uncle, can we
Hello?
have the Saturday class on the evening? Yeah, uncle, is it better?
Yeah. What do you asked?
Can we have the Saturday class in the evening?
Saturday class in the evening, very tough, man. Can you come after 6?
After 6, okay, uncle, because I have exam on that day.
Okay, 6 p.m. to 7 p.m. we'll do Saturday
Sure,
class.
uncle. Yeah.
Okay, yeah.
Okay.
Saturday 6 p.m. to 7 p.m. Fine.
Okay.
Okay, thanks, man. Next week, I will have a problem because I have to go out of station on Wednesday and Thursday. So that also we will do Thursday problem on Saturday. 2 hours we'll do.
But Saturday 6 to
Or Friday morning also we can do.
Friday morning. Yeah, Friday morning.
Next week, Friday morning. Next Thursday, I'm saying, not coming class.
Okay, yeah. Next Thursday, 16.
Next Thursday class, when we can do?
We can
I can do it on Friday morning, this way, 9:30 to 10:30.
Monday morning, okay?
Huh?
Monday morning.
Monday morning after that, huh?
Yeah.
Or Saturday evening we can do.
Okay, uncle. Saturday evening.
Next Saturday also you have exam.
Yeah, I might, uncle.
Okay. Friday morning also you have to exam. Okay. Then we'll do Monday then.
This Friday is a holiday.
Coming Friday is holiday. We don't have holiday, no. This Friday is holiday, then let us have Friday morning.
Yeah, Friday morning we can do.
Friday morning. Instead of Thursday evening 5 to 6, let us have Friday morning.
Okay, uncle.
Okay?
Yeah, sure.
If you are not able to come on Friday morning, then we'll do Monday morning.
Monday
But
morning.
try to finish on Friday morning.
Sure.
Okay? Thank you, boss.
Thanks, uncle. Have a nice day.
Have a nice day. Bye-bye.